Alright, we're going to wrap up our 2.5 lesson on implicit differentiation. And in our last video I said we're going to wrap up the lesson by looking at two more examples. So we left off on example 5, which means we're now on example 6. We're going to be given x squared plus y squared equals 25. We want to find the second derivative of this. We haven't had to do that yet. Whoa. We have found the second derivative in previous videos, just not using implicit differentiation. So we're going to first find the derivative implicitly of the first derivative, and then we'll from there derive it one more time, or differentiate it one more time. So if we differentiate with respect to x, we're going to have 2x plus 2y y prime equals 0, and then we can subtract 2x and have 2y y prime equals negative 2x. And we want to solve for y prime, so we're going to divide by 2y. Y prime would be negative 2x divided by 2y, but we can simplify and divide by 2 and get negative x over y. So that is our first derivative. We want to find the second derivative, and we have a quotient here, so when we're finding the second derivative, which I'm going to do here in blue, just so we can see them in different colors, we're going to have to take the denominator times the derivative of the numerator, subtract the numerator times the derivative of the denominator, and divide that by the denominator squared. Now let's clean this up. If we clean it up, we're really just going to be left with a negative y plus xy prime over y squared, but we know y prime. Y prime is negative x over y. So we're going to have negative y plus x times negative x over y all over y squared, which I am going to need more space, so I'm going to copy this onto another blank page. So let's multiply the x and the negative x over y. We're going to have negative y plus negative x squared over y all over y squared. And then we don't like having fractions or rational expressions, so we're going to, in our numerator, actually add those, which means we have to rewrite this, multiply everything up top by y. So we're going to have negative y squared plus negative x squared, which is just minus x squared over y, and that's all over y squared, which, again, we don't like writing things like that. So we can write it as negative y squared minus x squared over y. And if we use our rules for dividing fractions, we can multiply by 1 over y squared instead of dividing by y squared. So we're going to end up with, in fact, I'm going to just factor a negative out of negative y minus x squared, make it negative, and then our fraction. So y squared plus x squared over y cubed. Now we also at the beginning of our problem knew, or were given, that x squared plus y squared is 25. So we can replace our numerator, which y squared plus x squared is the same as x squared plus y squared. Let's replace that with 25. So we've got negative 25 over y cubed, and that is our second derivative. So we finish example 6. Let's look at our very last example, example 7. We are given x squared times x squared plus y squared equals y squared, and we want to find what is y prime. So let's start by distributing our x squared into the parentheses. So we're going to have x to the fourth plus x squared times y squared equals y squared. Then we can start differentiating everything. So our derivative of this first term is going to just be 4x cubed plus, we've got a product here, so we're going to go x squared times 2y y prime plus y squared times 2x equals 2y y prime. So I'm going to clean this all up a little bit. I have 4x cubed plus x squared. In fact, before I write x squared, I'm going to write my 2. X squared y prime plus 2x y squared equals 2y y prime. And now I'm going to move all my terms with a y prime to the other side. So in my next line of work, I'm going to have 4x cubed plus 2xy squared, because I'm going to just move the 2x squared y prime to the other side. So that's going to be equal to 2y y prime minus 2x squared y prime. Now on the right, both terms have a y prime, so I'm going to factor that out. And my left side stays the same. And now to solve for y prime, I'm going to just divide by the 2y minus 2x squared y. So my numerator is going to be 4x cubed plus 2x y squared divided by 2y minus 2x squared y. And we have finished finding our derivative, which means we've even finished lesson 2.6 on implicit, in fact 2.5 on implicit differentiation. I was getting a little ahead of myself with 2.6.